Hello, hello, welcome everybody. This is Miss MC Squared coming at you with Big What on Waves. All right, so we're gonna go through this and you have your slide with your Doodle notes on waves and you will be able to put the information in that you need. All right, so first off here, waves are everywhere. In fact, you can observe many different kinds of waves every day. You see waves that move through matter, such as those that cause water to rise and sink in the ocean. You feel waves when you feel heat, hear wave sounds as they move air particles around. So waves are literally everywhere. Now, a wave is a regular pattern of motion created by a vibratory disturbance. Okay, that's pretty technical, but a wave is a pattern, okay? And there's some sort of disturbance that happens. And a wave can't move, it can move through matter, but it actually doesn't move matter. We'll cover that in a second. Some waves can even move through a vacuum. So a vacuum is a space where there is no matter, right? So thinking about that. So a wave transfers energy as it moves from place to place. So what is a wave? A wave is a transfer of energy through a regular pattern from some sort of disturbance. And it can travel through matter or it can travel through a vacuum. It depends on the type of wave. You can see energy carried by a wave traveling through matter. The movement of a wave is actually movement of energy through matter. In this picture, dipping a finger in water is a vibratory disturbance. So that's that disturbance that we were talking about. And that disturbance, that motion, right, it has energy to it. And so the energy of that motion is being carried through the water in this wave. So that creates a wave, it travels through the water. The movement of the wave is actually the movement of energy. Now, most waves travel through a medium that we are going to be interacting with. A medium is a substance, so gas, liquid, or solid. And that's what this wave is traveling through. When a wave travels through a medium, it causes particles in a substance to oscillate, so go kind of back and forth. An oscillation is a repeating and regular vibration. It is a back and forth motion across a point called an equilibrium. Equilibrium is also known as the rest position. So you have those particles at rest, okay, object at rest wants to stay at rest, and then energy is added to it and they start to oscillate up and down, okay? Or it can also be side to side, but I'll get to that later. But the thing is, they always come back to that rest position. They don't transfer the matter. The particles don't move away. It's the energy that is going. The particles themselves, the medium themselves, just go up and down and then go back to that equilibrium. Mechanical waves. All right, so mechanical waves are waves produced by a mechanical movement or a vibrating object. All right, so mechanical waves have to have a medium. They have to have that solid, liquid, or gas to transfer that vibration through, because you have to have something to vibrate and continue to vibrate in order for the vibration to go. If you didn't have, it's like those particles hitting each other, all right? And if there weren't no particles, then they wouldn't have anything to hit. So mechanical waves can't travel through a vacuum. Mechanical waves transfer energy through a series of collisions. So here's how. An initial particle in the medium is disturbed. The particles collide into other particles in the medium. Those particles then collide into other particles, and the collision continues to transfer energy through the medium. There are three types of mechanical waves: transverse waves, longitudinal waves, and surface waves. In a transverse wave, the particles of the medium move perpendicular to the direction of the movement of the wave. Wait, what? Okay, so perpendicular, like this, right? And then we have parallel. So you have, parallel, perpendicular. So 90-degree angle versus in the same direction, okay? So can't get my arms to move the same direction. So the wave's moving this way, all right? But then the particles move up and down. Like you see, I'll try, right? The wave is going this way, but my sections of arm are moving up and down. So that would be a transverse wave. So because it's moving perpendicular to the direction of the wave. And so that is how you know the difference. Which way is the wave moving, and how are the particles in the wave moving? I have this video for you. Okay, we've got transverse and longitudinal here. So here we've got particles moving. See, the wave is moving from left to right, but on the top one, the particles are going up and down, right? Causing that wave, and you are able to see that wave, but the particles aren't moving along the wave. It's harder to see on this one, but the same thing is happening here. But here, the particles like condense and then knock into each other, but the particles are actually staying still. They come back to that equilibrium point. Like if you watch this dot in the middle here, it just kind of goes back and forth, back and forth. It doesn't move across the whole wave. Okay, a transverse wave moves across the medium. Particles oscillate in a vertical direction. In other words, as a transverse wave moves left to right, the particles in the medium move up and down, just like we were talking about, perpendicular. So like a rope, when a person disturbs or shakes a rope up and down, a transverse wave moves through the rope. The wave moves left or right while the particles, like it moves towards the tree, left to right, while the particles of the wave move up and down. In a longitudinal wave, we have these things called refractions and compressions. So a longitudinal wave moves across a medium, particles oscillate parallel to the direction of the wave. This produces areas where particles are compressed or spread out. So the compressed part are compressions, and the spread out areas are refractions, like rare fractions. So a part of it, fraction, that's rare for you to see particles. That's how I remember it. So the particles are moving left to right, and the wave is also moving to the right. Here you see this longitudinal wave, and you see the particles in there. They don't actually move all the way down the wave. They just are moving back and forth. That energy from that vibration of this object at the beginning here is, that energy is being moved all the way across. Here you can see the particles being outlined and pointed at, but the wave itself is going all the way across. The energy itself is going across. So when a slinky is disturbed, a longitudinal wave moves through it. The wave moves to the left or right, causing an area of the slinky to be compressed and spread out, or a refraction. Now, when it goes down the stairs like this, it's harder to see the total wave. You might think, oh, well, it's kind of like a transverse wave, but really it's being compressed and then it's opening up, and it's in that same direction as where the slinky is going. So you can do both a transverse wave or a longitudinal wave with a slinky. So transverse went up and down. Longitudinal, you see it's compressing across. It doesn't go up and down. So that's longitudinal. Up there is transverse.
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves. In a transverse wave, the disturbance that makes up the wave is perpendicular to the direction in which the wave travels.
All right, there you go. So all these videos are in the PowerPoint. Now, let's play transverse or longitudinal. If I knew how to do sound effects, so I do cheering and clapping. Oh man, it's everybody's favorite game. All right, I'm gonna have a thing, and you're gonna need to decide which one is this. Is this a transverse wave or a longitudinal wave? Do you see it? Actually, like the world record for longest wave. All right. Okay, so we're thinking about two things. Which way did the wave move? So it was moving along the horizontal, right? Like left to right. It's kind of going to the left. Which way did the particles or the people move? So to make that, how did the people move? How do you make a wave, like a crowd wave? Do you move your body left to right? Or do you stand up and sit down? You stand up and sit down, right? So wave moved left to right, particles moved up and down. That would be a transverse wave, perpendicular. Okay, let's see. Lots of waves happening here. Different ways, but think about there are two ways of determining what kind of wave it is. Okay, so which way did the wave move, left or right, or up and down? Or it's in his sense, and what we could see, you could go also, it was moving away from him, right? It's moving away from him down that line, down that straight line. Then which way did the particles move? So the pieces of rope, did the pieces of rope go like away from him? Or did they go up and down or in and out? Either way, up and down, in and out, it is still perpendicular to the direction of the wave. Okay? So again, did I get you? It is, again, a transverse wave. So surface wave is a combination of longitudinal and transverse. Surface waves are called so because they travel along the surface of a medium, such as land or water. Only particles on the surface of the medium oscillate. Okay? So we've got some different changes of position here. Some are small, some are bigger, right? And because of those oscillating particles on there, sometimes the floating things can get carried away, right? They can kind of push those different things, but the medium itself is still kind of is still staying the same. In a surface wave, particles oscillate parallel and perpendicular to the motion of the wave. The combination of these motions cause particles to move in a circular motion. So here's some wave properties. Waves are characterized by properties. Some of these properties are amplitude, wavelength, and frequency. We're going to talk about that a lot regarding energy as well. We're going to combine the two. So amplitude is the height. And the height of the wave is the maximum displacement or movement of the wave from the rest position or equilibrium. Amplitude is usually measured in meters, okay? So it's actually the physical distance moved from that rest position. So there's amplitude from the crest right there to the equilibrium point, that rest position, or the trough, that bottom part of the wave to the rest position. Either one is amplitude. Doesn't matter which one, because they're going to be equal. They're going to be equal. So you're learning some vocabulary for waves. Crest is the top, trough is the bottom. Then we've got amplitude, rest point. For mechanical waves, amplitude is related to energy of the wave. Waves with a higher amplitude carry more energy. For sound waves, amplitude corresponds to loudness. So amps, how many amps it has, that's how loud it is. So it's low amplitude, high amplitude. So notice it's the same like number of waves in this space, but these ones are little and these ones are big. So this would be louder, right? Which you're familiar with looking at different things like that. Wavelength is the length of one complete wave. It represents with the Greek word lambda, or Greek letter lambda. Wavelength is usually measured in meters. So the wavelength is also measured in meters, that distance from when it reaches a crest to a crest, but it's any same point on the wave. All right, so you could go crest to crest, trough to trough. All right, so that's the wavelengths. So the frequency of a wave is the number of times a wave circles in 1 second, and it's measured in hertz. So for frequency, the units are hertz. So there you have it, everybody. We have all this different information on waves. And also, I want you to think about energy with that. So if you have a really long wavelength, that means that a wave is taking a long time for another wave to happen. But think about with the rope thing. If he was going really, really fast, that would make a lot of waves in a short amount of time, right? So then if you have a shorter wavelength, if you have a lot of waves in a shorter amount of time, those waves are going to be closer together. So the smaller wavelength, what would be the energy for that? If they're closer together, that would mean that there's more energy in there. So the more waves in an area, that would be the more energy in there. So the shorter the wavelength, higher the energy. They are inversely related. Whereas with amplitude, the greater the amplitude, the greater the energy. They are directly related. All right, so I hope this helped you learn about waves, and I will talk to you guys later with more awesome information on the what on waves.